right, let's solve some trig equations. You're going to use some of the same techniques that you used last week, uh, but with a few different strategies. So the first strategy that you're going to use here is that you're going to change this trig equation into an equation of the same function. So you're going to have to try to change this to tangent or this to secant. Well, 1 plus tangent squared is secant squared. So we're going to use the Pythagorean identity here. So I'm going to go 1 plus tangent squared equal to secant squared. So I'm going to make that substitution. And then this is a quadratic type equation. And so I've got a squared term, a non-squared term, and a constant. So I'm going to arrange these. And then this is going to factor just like a quadratic would factor. And the first term is tangent of x and tangent of x. And then the only two terms of 1 are 1, and they both have to be negative. So that we have -1 tangent, -1 tangent adds up to -2 tangent x. So since each of the factors are identical, I'm just going to try to find out what one of them, what's the solution for x for one of them. And to do that, you solve for the tangent of x, add 1. And so now let's try to find the angle so that the tangent of x is equal to 1. So what angle has a tangent of 1? So the reference angle would be 45. And then the tangent is positive in quadrant 1 and quadrant 3. So the two angles, if I were to do if I were to leave my answer in this way, which I'm gonna leave my answer in a couple different ways. But if the directions were to solve for x between 0 and 360, then I would say having a reference angle of 45 in quadrant 1 would be a total rotation of 45, or having a rotation that ends up in quadrant 3 would be 180 plus 45. So that's 225. So if this were the directions, then those would be my two solutions for x. If my solutions were solved for all in degrees, then I would have to name all angles that are coterminal with a 45-degree angle. So the rule is that you have to add multiples of 360 to that. So we'll just go plus 360n, where n is an element of the integers. Now I'm not making you write this part, but you need to understand that this is 0, 1, 2, 3, 4, -1, -2, -3. So really the solutions that we're talking about are 45 plus 360 times 0, which is 45. 45 plus 360 times 1, which is 405. That's coterminal with that 45-degree angle. And then the negatives as well. So x equals 45 plus 360 times -1. So that's 45 minus 360, which would be -315. So there's all kinds of angles that are coterminal with 45, and this is how we represent it. So that would be half of all the solutions, and then this would be the other half in degrees. So if you were to solve for all solutions, that's what you do. If you were to solve for solutions between 0 and 360, that's all there is. Now, if you were supposed to solve for all solutions in radians, then the radian that's equivalent to 45 is pi over 4 plus 2 pi n instead of plus 360n. So that would be half of your solutions, and 225 is 5 pi over 4s. It's 545. So if you needed to make the conversion, 225 times pi over 45, you'd have to think about how many 45s are in 225, and that would be a total of 5. So this is equivalent to 5 pi over 4. So 5 pi over 4 plus 2 pi n. And again, remember that to be in quadrant 3, the numerator is 1 more than the denominator when you're talking about radian rotation. So you might be asked to leave the answer in different forms, so you just have to read the directions to what you're asked to do. So let's try another problem. Let's make an equation in terms of the same function, but let's use a reciprocal identity. So secant is 1 over cosine, so I'm going to change this function into 1 over cosine. I think what we'll do is I'm going to just turn to a blank page here. I'm going to write the problem down. So here's the original problem. Just going to double check that that's right. Okay, so that looks good. So I'm going to change, and you could do it either way. You could do it either way, but I'm more comfortable working in sine, cosine, and tangent. So I'm going to change this into 1 over cosine. So 2 times cosine of x minus 1 equals 1 over cosine. So anytime you have an equation with fractions in it, we want to try to eliminate the fractions. So the rule here is let's get rid of this cosine by multiplying the left and the right. Make sure you multiply everything on the left, brackets, and everything on the right by cosine. So 1 is the value on the right, and then if we distribute that, we would have 2 cosine times cosine is 2 cosine squared minus cosine equal to 1. And again, it's a trig function that is like kind of quadratic with that squared, non-squared, and constant term. So I'm going to use the zero product property and factor that. So 2 cosine x cosine x, front times the front is 2 cosine squared, and we have the last that is -1. So I need a 1 and a 1, but I need the insides plus the outsides to be a -1. So I'm going to make this a negative and this a positive. So I'd have 1 cosine minus 2 cosine is -1 cosine. So here are my two factors. I'm going to set each of those factors equal to 0 using the zero product property. And I'm going to solve first for the cosine of x, so -1 divided by 2. Here, add 1. And let's just find the angles between 0 and 360 first off. Because if you're to find all of them, you have to add 360n anyhow. So let's just find the angles between 0 and 360 that make this true. So the reference angle that has a cosine of, just ignore the negative for a second. Don't ignore just ignore the negative and just think about 1/2. What angle has a cosine of positive 1/2? And that would end up being 60 degrees. So what angle would have a cosine of -1/2? We got to think about our quadrants. All functions are positive quadrant 1. The sine is positive in quadrant 2. Tangent's the only one positive in quadrant 3. And the cosine is positive in quadrant 4. So the cosine is negative in 2 and 3. So 180 minus 60 is 120. So that's the angle in quadrant 2 that has a cosine of -1/2. And 180 plus 60 is 240. So those are my two angles that have a cosine of -1/2. And what angle has a cosine of 1? Well, that would be 0 degrees. So these would be your three angles between 0 and 360. Again, if you wanted to name all the solutions in degrees, it would be 120 plus 360n, 240 plus 360n, where n is an integer, and 0 plus 360n. If we wanted to do it in radians, we would think about the radian equivalents. Remember that 60 is pi over 3. So this angle is 2 pi over 3. It's the angle in quadrant 2. Remember, 1 less than the denominator, plus 2 pi n. This would be in quadrant 3, so the numerator is 1 more than the denominator, plus 2 pi n, and 0, plus 2 pi n radians. So answer your problem accordingly to whatever directions are for the problem.